electric cells and batteries. In electric cells, there will be an electrolyte and two electrodes. So here there is a symbol electric cell. So electrolyte is sulfuric acid and carbon electrode is acting as the positive terminal. Zinc electrode is acting as the negative terminal. So if it is connected to an external circuit, there will be a current. So there will be chemical reaction. So electric cell is a device which converts chemical energy into electrical energy. So when this is connected to an external circuit, electrons will be flowing from negative terminal to positive terminal. Conventional current is from positive terminal to the negative terminal. Then for an electric cell, there is an electromotive force. Then it is denoted as EMF, electromotive force. So electromotive force is a misnomer. Actually, it is not a force. It is the potential difference between the terminals when the electric cell is not sending current. So directly if you connect the terminal to a voltmeter, there will not be current because voltmeter is an instrument with a very high resistance. When the electric cell is not sending current, the potential difference between the terminal is known as electromotive force. So if you connect this to an external circuit, for example a bulb, then if you connect to a potential voltmeter, then it is the potential difference. EMF is also the potential difference when the cell is not sending current. When you connect this electrode to a resistance, there is a current. Current is from positive terminal to the negative terminal in the external circuit. Inside it is from negative terminal to the positive terminal. So during this flow of current, there is a internal resistance. So internal resistance is the resistance offered by the battery or the cell to the flow of current. When you connect a number of cells either in series or parallel, it is known as battery. Now let us see how to determine internal resistance of a cell. Now let us see how to determine the internal resistance of a cell. Here a cell is connected directly to a voltmeter. Voltmeter is a device with a very high resistance. So it's drawing a very small current for the deflection. So it can be considered as open circuit. At that time, voltmeter will show the EMF of the cell. It is denoted by this Greek letter psi. Now, potential difference between the two terminals of the circuit in the open condition is known as EMF of the cell. Now, same cell is connected across an external resistance capital R. The small r is the internal resistance of this cell. Capital R is the external resistance. Now cell is sending a current. In this case cell is in the open circuit, so there is no current. Now there is a current. Now the voltmeter will give you the potential difference. So that potential difference V is equal to I into R, where I is the current through this resistance and R is the external resistance. Because of the drop in the potential drop in the internal resistance, potential drop across the resistance will be lesser than the EMF of the cell. So V is equal to psi minus IR, where psi is the EMF of the cell. Now potential drop across the resistance is lesser than the EMF. Now you rearrange this expression. So IR is equal to psi minus V. Now here IR is equal to V. Divide this equation by this equation. So I will get cancelled. So you will get R by R, where R is the internal resistance of the cell. So R by R is equal to psi minus V by V. So R is equal to psi minus V by V into R. So using this relation, we can determine the internal resistance of the cell, because we know the EMF of the cell, that is psi, and R is the external resistance and V is the potential difference across the resistance. Then power is given by this relation, I into psi. Then for this psi, from this equation we can write V plus IR. For this V you can write IR. Now remove this bracket. So you will get P is equal to I square R plus I square small r. So this is the power delivered to the internal resistance. So the power delivered to the external circuit will be lesser than the power rating mentioned in the battery. So for a good battery, I square R will be very much lesser than I square R will be very much lesser than capital I square R. Thank you for watching.